This video is going to talk about how to represent things in expanded form. So, when we have the digit 4 in the number 43, that digit 4 doesn't just mean 4. It actually stands for 40. When we have the digit 3 in 43, because it's in the ones place, that just means 3. But because the 4 is in the tens place, it stands for 40, or 4 times 10. So 43 actually means 40 plus 3. And 40 plus 3 is an example of writing something in expanded form. So they want us to write each of these in expanded form, just like on the previous slide. Go ahead, give it a shot on your own, and when you come back, we'll talk about it. Welcome back. Let's go ahead and take a look. 52 would be the same as saying 50 plus 2. 81 would be 80 plus 1. That's an 80. 76 would be 70 plus 6. And 92 would be 90 plus 2. Ooh, now we have bigger numbers. Go ahead and try these and then we'll talk about it. Welcome back. 352 is 300 plus 50 plus 2. And you can see that these are starting to get a little bit longer here. What I like to do to help keep track is I'll write it a slightly different way, and we'll see if it works on here. So this 3,896, I'll write them out below it, and I'll say 3,896. And I'll just put a plus sign after each one. And then when I can write it out on a long line, I can make sure that I have the correct number of zeros for each number. So let's look at 784. I'm going to do the same thing. I'm going to write it going down. And you can see I'm just pulling each number down and then putting a 0 after each number. And then I'm going to go back and put in plus signs. Now, if I were to write this on the computer or to turn it in, I would just go ahead and convert all of this and just rewrite it. And I have my commas in there, so I'm good to go. But I like the visual of how this works because it helps me, that doesn't go there, that's a lie. It helps me to make sure that I have the correct amount of zeros. Now, let's go ahead and write 350 in expanded form. That's 300 plus 50. 305 is different. That's 300 plus 5. You might notice here that we don't have anything in the ones place here. We could put plus 0. That really helps with making sure that we don't miss anything, but it's not necessary. We could have put plus 0 here to show that there are no tens places. But again, it's really not 100% necessary. They want you to write these numbers in expanded form. Go ahead, give them a shot on your own, and we'll talk about it when you come back. Welcome back. So for letter A, it will be 200 plus 7. Letter B will be 200 plus 70. Letter C, 700 plus 2. Letter D, 700 plus 20. When we look at letter E, we're going to have, I'm going to go ahead and put letter E up here. I have a feeling I'm going to run out of room. 6,000 plus 100 plus 3. For letter F, that's going to be 1,000 plus 3. For letter G, I'm going to go ahead and start letter G over here. That's going to be 20,000 plus 9,000 plus 30 plus 1. And then for the letter H, that's going to be 7 million plus 30,000 plus 2,000 plus 500 plus 30. That is terrible handwriting, and you have my apologies. I'm doing the best I can on this. They want you to write 2,135 in expanded form, which is 2,000 plus 100. Too many zeros in there. That's why I like to go up and down to make sure that I've got it correct. Plus 30 plus 5. So you can see that when we write in expanded form, the first thing that we're doing is we're breaking it apart into different multiples. I have the ones, the tens, the hundreds, the thousands, and what we're doing is we are showing how many ones, how many tens, how many hundreds, how many thousands. So this is a representation of that same number, 2,135, that we wrote in expanded form. They're showing it using the base 10 units. So we have 2,000s, 2,000s. We have 100. We have 3 tens or 30. And then we have 5. And you can see how those add up together. They want you to do that with these. You can go ahead and draw that. Sure, I'll go ahead and draw it for you. Pause the video, give it a shot. Welcome back. You knew it was coming. So, the first thing we have, and to draw these shapes, the first thing you do is draw a rectangle. And then we put that somewhere else. And then you draw a second rectangle. And then you connect the bottom left corner to the bottom left, the bottom right corner to the bottom right, the top right corner to the top right, and the top left corner to the top left. And then if you were to connect the dots to the actual corners, you would have a shape. So that's 1,000. I need 2 hundreds. I need 4 tens. And I need 3. And there you go. Those are the exact shapes from down there. You're welcome. So another way of writing this. How many 10,000s do we have? What number's in the 10,000 spot? 3. How many thousands do we have? 2. How many 4s? How many 10s? And how many 1s? So I have 3 10,000s, 2 thousands, 4 hundreds, 2 tens, and 7 1s. You go ahead and give this one a shot all by yourself. When you come back, we'll talk about it. Welcome back. Let's go ahead and take a look. How many 10,000s do we have here? This is actually a trick question. There are no 10,000s here. The 10,000 spot is empty, so we're going to put 0 10,000s, 4 thousands, 5 hundreds, 8 tens, and 9 1s. Go ahead and give this one a shot. You'll notice that they skipped some things out because it wasn't important to put in. There are no thousands, so they don't have a 1,000 spot. How convenient. Go ahead, pause the video. We'll talk about it. Welcome back. So how many 10,000s? Well, 3 is in the 10,000 spot. How many tens? Well, 6 is in the 10 spot. How many 1s? Well, 1 is in the 1 spot. So there we go. They want you to go ahead and write the expanded form using place value words. Only write the place values that we need to. That means that we're going to get out our handy dandy keyboard that we were totally prepared to do, because I just looked at this and forgot. So when we have the first one on there, we have 5,000, 5,000s plus 700s plus 7 tens. We're not going to put anything about the 1s because, well, there are no 1s. Let's look at the next one. You go ahead and start the next 2 on your own, and when you come back, we'll talk about it. Welcome back. So we have 800s. Oh, I should be 800s plus 4 1s. Simple as that. We don't need any tens because we don't have any tens. For the last one, we have 4 10,000s plus 300s. Awesome. We're all done. They want you to do the same thing here. If you want to give that a shot on your own, you are welcome to. Ooh, now we get to combine the expanded form. Let's go ahead and take a look. 30 plus 7. All we're doing is adding here. 30 plus 7. We could line it up and we could say, ooh, what's 30 plus 7? And you could see that it's 37. Or you could know that these are all expanded form and we're just putting them back into standard form. 40 plus 3, 43. 90 plus 9, 99. 300 plus 50 plus 7 is 357. 400 plus 20 plus 9, 429. 800 plus 60 plus 1 is 861. What is 500 plus 7? Is there a 0 in the number? Yes, we know that because there's no tens place. So we're not just going to write 57. That would be silly. That number is 507. And we can double check that when we line it up. That's why putting zeros in numbers are very important. In expanded form, we don't need to write the 0 because expanded form is just the addition statement. And adding 0 doesn't add anything. But it's still super important. It's a placeholder in the actual number, and it's very important to remember. So they want you to write out these numbers for expanded form. Go ahead, give them a shot on your own. We'll talk about it. Welcome back. So the first one is 302. The second one is 230. See how that placeholder makes a difference in where the 0 goes. And the last one is 5,000 plus 60. There's no hundreds, so I'm going to put a 0 in the hundreds place. Plus 60 plus 1. Go ahead and give these a shot. Welcome back. Let's go ahead and look at 7,000 plus 3. 80,000, 300. 60,000, 49. Ooh, a bonus. This one's even out of order. How fun. So now we have to be super careful. I might even see that the biggest number has 7 digits. So I'm going to go 1, 2, 3, 4, 5, 6, 7. I'm going to put my commas in there. And I'm going to see 30,000. I would put that 1, 2, 3, 4, 5 numbers over. 1, 2, 3, 4, 5. The 3 goes there. 8 million. Well, that's in the millions place, so I'm going to put the 8 there. 10. I know where to put the tens. And 400, that 4 is in the hundreds place. So I'm going to put a 4 there, fill everything else in with zeros. Now they want you to fill in the blank. 200 plus what? Plus 3 equals 253. Well, we have a 2. We have a 3. We're missing that 5. That 5 is in the tens place, so I'm going to put 50. Go ahead, give the next two a shot. We'll talk about it when you come back. Welcome back. The number that's missing from the next one, I don't see a 4, and that is definitely going to fit on the line for me, so that's going to be 4,000. And then for the last one, we're missing the 4 again. This time it's going to be 40,000. That's a 0, not a 6. All right, that totally looks better. All right. Ooh, now these are out of order and we have to find the missing one. Well, I see the 4,000. I see the 300. I don't see the 20. There we go. You see how changing things out of order makes it a lot harder to read? That's why we always do our best to go in order. What is the sum of the digits in 234? This is like what we do to test our 3 divisibility rule or our 9 divisibility rule. So the sum of the digits would be 2 plus 3 plus 4. 2 plus 3 is 5 plus 4 is 9. Let's look at the sum of the digits in 4,121. 4 plus 1 plus 2 plus 1. I'm going to do 2 plus 1 first. 2 plus 1 is 3. Then I have 4 plus 1. And I know that I can switch around the order in which I'm adding things. So normally I'd go from left to right, but because it's all addition and there's no parentheses or anything, I know that I'm able to change the order of addition and I'll still get to the correct answer. 4 plus 1 is 5. 5 plus 3 is 8. They want you to make these numbers using base 10 blocks. Go ahead, try that in your notebook, and we'll talk about it when you come back. Welcome back. 234 is 2 hundreds, 30 tens, 4 ones. 4,121, I get to add 4 thousands. Yay. 1, 2. You can see how perfect these are. 3. Wow, that one's especially perfect. 4,121. And you can see that here we had 1, 2, 3, 4, 5, 6, 7, 8, 9. So when we added up the digits before, we got 9. And here we have 1, 2, 3, 4, 5, 6, 7, 8. So when we added up from before, we got 8. So that those adding up the digits just tells us how many pieces that we're going to use if we use base 10 blocks. Now, they want you to use base 10 representation, those same blocks, of a number of for a number that has digits that add up to 11. So make a number using 11 blocks. All right, let's go ahead and look at what digit is twice the ones digit in 432. So first of all, what's the ones digit? The ones digit is 2. What digit is twice 2? Well, that would be 4. 4 is 2 times 2. Go ahead and try the next one on your own, and we'll talk about it when you come back. Welcome back. What digit is twice the ones digit in 6,723? Well, the ones digit is 3, so twice that digit is 6. Twice the ones digit in this number? Well, the ones digit is 1, so 1 times 2 is 2. Which digit is twice the ones digit? Double nothing is nothing. Okay. So I've got some exercises here for you. In the number 265,321, which digit is 3 times the tens digit? So the tens digit is 2, and you want to know what's 3 times 2. 3 times 2 is 6. Write a number whose hundreds digit is twice the ones digit, or an odd number whose 10,000s digit is twice its hundreds digit. That's going to be for you to do on your own. Bonus! I'm going to let you do that one on your own too. So in this number, we want a digit that is worth 300 times as much as another. So let's go ahead and look at this. We want something that's 300 times as much as another. We're not necessarily looking at the just the worth of the digit now. But if I take this 3 and I say 300 times 3, I'm going to get 900, which you can see right there. And they also want one that is 4 times as much of another. So, for example, we're going to multiply 400 times something, and we're going to get a different digit. So let's look at this 5. Let's look at 50. It's going to be harder for me to show this now. What's 400 times 50? Well, first of all, the zeros, I'm done with that. That doesn't count. 5 times 0 is 0. 5 times 0 is 0. 5 times 4 is 20. Imagine that each thousands block has shrunk. Now they're going to start using bigger numbers and more complicated things. Which base 10 block could be used to represent a million? So if now we're going to use this as a thousands block, first of all, what would you use for 10,000s? Well, 10,000s, that would be 10 of those. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 perfectly placed blocks. And then for 100,000, we would go to this one. What do you think we would use to represent a million? All right, I'm going to let you look through these real quick if you want to take a look. These are some challenge questions for you. Palindromes are lots of fun. All right. This is going to end this recording. Ladies and gentlemen, have a wonderful day.